cross-validation gives you another very nice tool, which is called jackknifing. And before I show you this app for jackknifing, let me show you the app that I had here, B305, where I introduced the sampling error on overfitting, right? So remember, I just took many new samples, and then I was able to see the variation of the regression coefficients. For example, for cubic model, you can see that was the variation, right? So strictly speaking, if I take a lot of samples, I can make a kind of interval for the regression coefficients, and then I can say, okay, probably it's the middle of the interval, this is the true regression coefficient, and then if this interval crosses 0, then probably this particular coefficient or this particular variable, this particular predictor is not important. The problem is that I need a lot of samples here. But this problem can be tackled if we actually use cross-validation, because that's exactly what we do in cross-validation. We emulate these many samples, right, by taking part of our original sample out. And that's exactly what jackknifing is, right? So you can see again, we have a population, we have a population model, and we have a global model made for all points from the sample, which you see as blue, like pale blue points here. So here we have coefficients. So you can see the gray bar, it's the coefficient for the population model, and the blue is the coefficient for the global model, right? Now, let's run cross-validation. In this case, a full cross-validation is used. Let's run cross-validation, and then you can see that we have different local models, right? We have different regression coefficients for the local models, and therefore we can actually emulate this variation here and variation here. And then because these coefficients, variation of these coefficients, they follow t-distribution or normal distribution, so we can use t-distribution if its sample size is small, we can make confidence intervals. And then you can see that again, if you look at this 95% confidence intervals, you can see that actually the population regression coefficient is inside, right? So that's the idea of jackknifing. And then you can also use jackknifing for actually tackle the overfitting in the similar way. So you can see that in this case, let me take a new sample, a worse one with a clear kind of curvature here, right? So you can see that this one is much far from 0. So let's see if we can detect it by using jackknifing, right? So I run jackknifing again. Then you can see that the variation is quite large, both for this one and for this one, for quadratic and for cubic. And then when I'm done with cross-validation and compute the confidence intervals, you can see that all confidence intervals here and here, they cross 0. And that's what tells us that probably this is not important and this is probably not important, right? You can also see that these confidence intervals are also larger because we have less degrees of freedom. However, if you make this first, you see that this is probably not significant. You remove it. For example, you say, okay, let's take quadratic model. You run this again, cross-validation, and you make the jackknifing. You can see this variation is smaller now. So you can see that the confidence interval will be a little bit more narrow. Let's wait. So, okay. But this one still, you can see that crosses 0, right? So if you take a linear model and then run it, and then again, when the cross-validation is done, you will find out that for linear model, indeed, both regression coefficients, they are important. They seem to be significant. They not very likely that they are 0, right? So this is kind of a variable selection. So you both have you tackle the overfitting problem, and also you can do the variable selection. So you can get rid of the variables which possibly not important for prediction of your y value. So that's what jackknifing is.